Assalamualaikum warahmatullahi taala wabarakatuh, and very good day to everyone. Alright, so basically this presentation is on experimental and simulation method. Okay, and me as a presenter, Zainohami bin Solihin from Mechanical Engineering Faculty UITM Shah Alam. Okay, so basically many final year student FYP, either is FYP1 or FYP2, uh, need the brief explanation on what is the right method, either for his experimental or simulation. So basically today we will talk on how the best method we should conduct for our study. Alright, so as per introduction, so basically research methodology is commonly acknowledged as the most important part of any research project that needs to be established before the actual data collection program begins. So basically it's like a roadmap. Okay, so you need to plan your roadmap very efficiently and accordingly. Basically it's to prevent any difficulties in the middle of your study. So basically most researchers in applied science or engineering or any other relevant course prefer the deductive approach, in which a problem is identified and then its cause and effect is confirmed by experimental data or proof. So basically you must know what is your problem first. You must identify what is your problem, and then you should know what is your relevant data you need to do. Okay, so at the end of the day, your data, your result is your main goal or is your objective you should do, and then you can discuss what is the relevant data is all about. And then for topic 1, for experimental method, for experimental we have two types. First we call it as a published method, secondly we have established method. So published method is the experimental done by other research. So basically the student will do the same research, the same experimental method, but maybe in differ in parameters, differ in any approach, or in the environment, or in the different climate. And then normally this published paper we can find in the journals or any other source of relevant publishing. Okay, and then student can cite their works. That citation you can put in the literature review. Alright, on established method, basically established is a newly experimental. Okay, which means that nobody has done the same study as you want to do. And so basically from that newly experiment, you must have the right method. Okay, so this right method, either you start from the beginning with using DOE, is a design of experimental. Okay, or you can use a ANOVA method or some kind other method, but that method, either DOE or ANOVA, is a established method and it's a common method you can use for a new experiment. Okay, and also from this experiment you can cite other works that may be similar to your works, but of course lah, it's not the same as your work because you are running a new experiment. but the most similar one, you can cite it and put it on your literature review. Okay, the established method is not recommended for degree level. Commonly, this established method is used by master's level and mostly for PhD student lah. So basically for degree level, you are currently suggested to do a published method lah. Okay, which means that you cite other works that may be similar with your works, and then you put the citation inside your literature review, and maybe the difference is on your environment or in your climates and so on and so forth. Okay, so we have two types: laboratory and field experiment. Okay, we look first in laboratory. So laboratory experiment is a standard testing method. Okay, either is being independently by the procedure by the developer, or laboratory scale investigation. Okay, so basically this standard is according to British Standard BS or American Society ASTM. Okay, it's a standard that being established worldwide. So for that current equipment, normally the British Standard or American Society Testing Material Standard is used as a guideline, and the commonly used for test material and the system used in related or to the research or investigation. Okay, state your laboratory procedure in the methodology. Okay, either you using a British Standard or American Society, depend, but you must state your procedure inside your methodology. Okay, and then we have a field experiment. Field experiment is the experimental carry out for the same purpose, which is to collect a data, and the data is to be analyzed and studied further, either in the laboratory or either you want to use as a validation for computer numerical models, and also it can be combination of 2 or 3 of the said techniques. Okay, the decision of the location of a experimenter depend on the objective and your scope of your research. Each method has its own strength, challenge, and limitation, as well as additional consideration to be included. Okay. So in this slide showing that the common experimental structure. So how to conduct your experiment? First of all, you must know what is your parameters. So from the parameters, you must know what is the theory and the mathematical model behind your problem. So your problem, you can roughly or graphically, you must identify what is the mathematical model influence your either your diagram, either your environment, either whatsoever, but you must know the theory behind it. From that theory, you can know what is the relevant parameter you need to be measured. Either your density, either your temperature, or your distance, or your velocity. Then from your parameters, you can specify which apparatus or tools or the procedure for your tools or your parameters to be used. For example, if you want to measure a distance, a length, if you want only recorded one decimal point, you can use a ruler. But if you have a measurement up to 3 decimal point, you cannot use a ruler. Maybe you can use a vernier caliper or micrometer. So gather your data in the tables and then tabulate your result. So this is the example of theory and governing equation. I take this picture from a laboratory experiment, MEC 451 fluid lab 1. So here showing the theory. The part 1 is the theory, whereby is a refrigerant cycle, which is you have a theory, the vapor compression cycle, the diagram, okay, and then what is inside the diagram. Then you can show your procedure. This is an example of the mathematical model. Of course, this is only a semester 2 students. So basically the semester 3 student. So basically the general equation is simpler compared to the final year project is at semester 7. So basically you must have a more advanced equation. So here in your lab also state the objective. Here I take from lab report MEC 451 MEC 451 lab fluid. So stated the objective. So this objective is what you want to find the parameter and the outcome from your lab. So here stating that the purpose of the experiment is to investigate the variation in coefficient of performance COPR of a vapor compression refrigerant system at different cooling load, and then the procedure stated here lah. So this is the common apparatus. Then from your procedure and then your objective, you must know that your objective is the variation of COP. So from this you can draw a graph. So this graph, load COP, power requirement. So this is your variation, load, and also something like this lah. So you can vary based on your data. Alright, we proceed into topic number 2, simulation structure. So this simulation is quite different from experiment. Okay, basically this simulation is based on mathematical model. It does not have any lab experiment, but we have lab experiment in validation. Okay, starting the firstly is develop a model. For simulation, you must develop a very simple model, as simple as possible, but that model will cover all your influence factor inside it. So you must know which one the critical point of your model to be analyzed. So the model you must have a very simple one, and it's a very catchy one. From that model, you must develop the governing equation because simulation is a mathematical approach. Governing equation is a must for a simulation process. Governing equation is used to define what are the parameters, what are the model, what are the equation you need to use, you need to click inside your simulation software. Okay, after you have developed your governing equation, you must run mesh independent studies. So what is the best mesh size for your current model? A simple model require a low number of mesh. A very complicated model require a large number of mesh. So, for example, ANSYS only for student version, it's only can cater up to 500 nodes, 500,000 nodes. So a more complicated model is being restricted. So basically you must have a very simple model if you want to run using ANSYS. After you done mesh independent studies, you can validate your result. You must validate the result in order to know your governing equation is the right equation. Normally, simulation approach, you can have the answers or the data required. But the question is either your data or your result produced by the simulation software is right or we cannot use. So basically the credibility of the data is being questioned. So in order to know your right data produced by the simulation software, you must do a validation process. So validation, after the validation is a must. Basically to know your governing equation is the right governing equation and your assumption for your governing equation is acceptable or tolerable. Then from your data you can tabulate a result. Depend on your objective, either you want to do a counter result or by using only average data. Depend on what is your objective and the discussion of your studies. Lastly, tabulate your result. So first we develop the model. Basically in this example is a PV panels. So PV panels is on the upper side and in the bottom side is the roof. So basically in order to have a very simple model, just draw a box, assuming that the top one is your panel and the bottom one is your roof, and then the upper one you can insert inside your ANSYS the material or the properties of the solar panel, and inside it, all of it we can assume as a fluid. The fluid normally for this model, normally we use a air. So for the air used, we assume is in the environmental condition with your Cp and Cv if relevant is on the normal ambient condition at 28 or 30 degree Celsius. So this is the model. So on the right also we have a model. So this is a box. So you must develop your model is at a very simplest way. The simplest way. You cannot run a simulation on a very complicated part, because the more complicated part require many nodes and mesh. So your computer, you have a problem with your computer, and also you have problem with the number of restriction nodes. Then from your model, develop your governing equation. So this is the example of governing equation. Governing equation is not intended to be solved. Your governing equation will be solved by using simulation software. But before you use the simulation software, you must know what is the basic governing equation. For example, here is a example of a solar flow, a flow of air induced by the solar. So the induced solar is based on the natural buoyancies or convection condition, which means that it's not a forced draft but it's a natural draft. So for a natural draft, use a Rayleigh number. For a forced draft, use a Reynolds number. So from this equation, you can define what is your continuity equation, momentum equation, and this is your turbulence model. So either is a turbulence or laminar model is based on your Reynolds number. If your flow consists of temperature, it's not only velocity but includes temperature, you must use a energy equation. So if you then you can define what is the temperature. So if your temperature has its source, for example, source from a fire or maybe from a solar, so you must know what is the value of that source. If, for example, here we have the source from solar, so your solar, you must define what is your sun angle, your hour angle. From that, you can define the energy being transferred toward your model. That energy transferred will influence your temperature. So here is the example of how much solar irradiate towards the model. So this value is being used as an input model, input value for the radiative or convective that influence your temperature inside your energy equation. So this is an example of governing equation you must do, but depend on the problem or the case of study you intend to do. Alright? Okay. So this is the independent study. So basically independent study is the number of mesh. So number of mesh is a number of nodes that you run depend on the model. So basically, if you have a very cost or is cost a very cost of model, So number of cell or number of node is very low. But example here is the velocity. The velocity is also being influenced. As your number of cell or your number of node increase, so your number of the velocity is also increased. This here is used based on the same input without any adding or subtracting any input. Without touching the input, you change only the numbers of cell. The velocity is fluctuated. So the mesh will be independent as your velocity is starting to constant. It's not at where of your velocity is constant. The number of node is the number of node is the numbers that you should do for your studies, for your model. So if let's say for example here, the number of nodes, number of cell starting to constant at about 200,000. So basically your model at least have 200,000 nodes, because after 200,000 the velocity remain constant. It's not fluctuating compared as the low number of cell. So here is the number of cell, the right number of cell, the best number of mesh you should conduct in order to have a reliable data. Other than that, you have a scale residual and also mesh flow rate. So these two is used as the how many iteration you should conduct. For example, you can run maybe 10 iteration, but the numbers of here, the number of your result will be higher fluctuating without any changing in your input data, input source of data. Only number of iteration, the result is fluctuating. So here you must do many times of iteration. In this example you have 1000. So basically in this result showing that maybe around 200 iteration is sufficient to get your data constant throughout the number of iteration, because the higher the number of iteration, the much lower your result will be. Same with mesh flow rate. So you have two types. Either you want to do a scale residual test or mesh flow rate test to find what is your best iteration. So here number of iteration for your mesh flow rate is sufficient if you conduct around 500 iteration, and from this maybe you can cut down the time used to run your simulation. Alright, so this is the example of result. This is the example I shown to you. So from these tables, what you can get, many types. So the result may be in terms of graph, but firstly you must validate your graph. So your graph you must validate with either your experimental, or you can validate with your any others, something like this. So you can validate with experimental, or you can validate your result with your others researchers result that run the same, the much similar, merely similar with your studies. So basically the validation is a vital one. So you need to be careful. You must do a validation to know that your uh, governing equation and your approach of your assumption is reliable, and the credibility of your data is being is near to accurate. Then from your validation, for example here you have I have a simulation and experimental data, so you can do the difference and put it in terms of percentage. So here we have example. In this example 1 is the contour result. In the simulation result, you have many approach to present your data. Maybe here in this section, I shown to you the flow of air on the gap. The upper gap is the solar panel. Sorry, this is you see the line. So this is a solar panel, and the bottom part is the rooftop. So this is the flow, which this is the temperature. So the temperature starting from your from the inlet towards your outlet. This is your inlet, this is your outlet. So basically the air move in. So at the end of at the outlet, the temperature is quite high a little bit compared to in the inlet. And this is the velocity contour. So we can see this is the inlet. So this is the variation of velocity. And here in the result, I show to you the result what I've done. Okay, so here I need to show the contour result, because here from before this I have only 50 mm gap from the solar panel and to the roof. So here from the gap I can see a contour, what we call it as a swirl between the solar panel and the roof. So this swirl here maybe in the simulation is only showing color, but in the real life that color, the swirl happening between the two, the higher the velocity, maybe it can affect the structure of the real item. So basically that turbulence here is only, the highest is only 3 meter per second. Let's say for example you have a typhoon around 15 to 20 meter per second. So which means that if you have this swirl between here, the highest the velocity, it can affect the structure of the body. So maybe the panel will be flown away by the wind because of the gap is high. So this result we need to show by contour. Alright, so also we can combine by contour and also by the graph. So here I show to you in the variation of temperature, and then I can plot the graph. Or you can put it, you have a average data, take average data. So for example, this variation, you can take the average data and then you can plot it in your graph. So here the result is shown by a graph. Okay, in y axis I have air velocity, and the x axis is in solar panel, the length of solar panel, the length. This is your length, so this is the length, this is the length, and the air velocities is inside the model lah. Okay, between the solar panel and the roof. Okay, so the right result, you must show something like this. You must have a trend line. So this trend line can be shown automatically. I can show you after this. Okay, so this trend line, you will have a equation, graph equation, the trend line equation. Either this is a parabolic or hyperbolic, depend. So here is we have a quadratic with a coefficient of determination of 0.98. So which means that this is near to the very low residual error. So right, so today I'm shows you how to develop a graph. Okay, basically this is the newbie tutorial or basic tutorial for, I know many of you have done many times to create a graph, but here I'm shows the right way how your graph should look like. Okay, for example, if you have something like these tables, so you need to construct a chart. Normally we pick a scatter chart, just pick one, something like this, a blank one is okay. Then you can click right button, so you can define what is your data. Okay, so legend here shows that what is your data. Okay, add, this is the x value, so this is your names, the series name, so put it here, air velocities. Okay, the x value is from, sorry, I need to wait a minute. Okay, all right, add series name, and then series x value, so that is your length. So basically the length here, this is the length, the y value, okay. Okay, so you have the simple graph. Either you want to edit what is your title for x value, you can put it here. Okay, so here is your distance. And in your x value, let's say this is the velocity. Alright, so you have a scattered diagram. So what you need to do is define a trend line. So how to define the trend line? So click at the nodes and then right click. So you have something like this, add a trend line. So either you want to do a linear exponent, something like this, or log, sorry, or power. So firstly you need to display equation and display the coefficient of determination. So coefficient of determination determine which is the best chart you want to do. Okay, so here the trend line, we have 1 2 3 4 5 6 trend line. Okay, which is the best is based on the r squared value or your CODOE. Sorry, COD coefficient of determination. So the perfect one will be 1.0. So near to perfect is the best trend line we can choose. So here either polynomial. So compared to trend line linear, polynomial give us 0.98, which mean that near to 1.0. So this is the best trend line, the suitable trend line for this graph. All right, and then you can other analysis your graph. Okay, how we can discuss from this graph? You have learned on what we can conduct, what we can analyze from the graph. So here I'm showing to you the at least example on the what we can do from the graph is by knowing the area below the line, below the trend line. So how to know the area is by integrate. So before you integrate, you must know what is your trend line equation. And then from this, you can know that from the integration is the velocity times your distance, velocity and distance. So if you have a density of the fluid and viscosity of the fluid, you can define what is the Reynolds number at any length of the solar panel. So assumption, that is where we need to define very briefly, because here, for example, the density of fluid is a constant for a normal environment. Let's say, for example, you define at a 28 degrees C environment, so we can check what is the density of the air at that current temperature condition. Also, from that, you can also check what is the viscosity of the fluid at that current condition also. So from here, this graph showing that the area below your trend line, we can know what is the variation of Reynolds number. In your study, fluid or thermal, you use a Reynolds number based on average velocity. So for a selected length, you must average the velocity to find what is your Reynolds number. From this experiment, you can define velocity at every length of your panels. You can define it each by each by using this graph. So that is the one type of discussion for the graph you can produce. Maybe you have another method, you can let us know. So this is the common mistake. Alright, so the same is a MEC 554 thermal fluid lab. Okay, so the same the objective is to find the COP. So the same the same equation given, but you have a discussion state here is the tables. It's not. The graph shows me is a PV diagram. The PV diagram. So basically here stated that variation of COP at different cooling load. So here is the enthalpy versus your load. Is incorrect. So this result is not showing what is your objective is all about. It's not fulfill or meet what is your objective. So this common mistake, basically you need to take away. You need to prevent it from occurs again. Okay, so that's all of my presentation today. If you have any question, you can WhatsApp me, or you can contact me at any means, or you can email to me at given after this. Okay, so thank you. I end my presentation.